Conversational AI multi-agent interoperability frameworks are crucial for efficient and effective interactions among diverse agents, including chatbots, voicebots, videobots, and human agents. The Open Voice Interoperability Initiative proposes a novel architecture, OVON, which establishes and enables interoperable interactions among agents through universal APIs based on natural language. This framework introduces a discovery specification framework for efficient lookup of agents providing specific services and obtains accurate information about these services through a standard manifest publication, accessible via an extended set of natural language-based APIs. The OVON architecture enables conversational assistants with any internal architecture to collaborate as long as they adhere to the communication standards. The framework introduces a discovery specification framework, which efficiently looks up agents providing specific services and obtains accurate information about these services. Unlike previous approaches, this approach makes fewer assumptions about the internal structures of the assistants, allowing for greater flexibility and scalability in conversational AI interactions. The researchers present a novel approach to conversational AI interoperability, enabling independent assistants to work together seamlessly. The Open Voice Conversation Envelope API facilitates this collaboration, passing user requests to secondary assistants that interpret natural language. The approach stands out for its loose coupling of assistants, supporting various technologies, and minimal requirements for integration. The Open Voice Interoperability Initiative has released the first version of the Interoperable Conversation Envelope specification, which enables agents to send events to each other, carrying information about utterances, whispers, invites, buy messages, and manifest requests. These events are standardized, allowing agents to communicate effectively, regardless of their underlying architecture or technology. The researchers propose using state diagrams to model the behavior of AI agents, illustrating their states and transitions based on specific events or conditions. This representation is useful for mapping the OVON interoperability specifications to the dynamic statuses and standard messages exchange. The state diagrams shown only describe states relevant to interagent collaboration, excluding internal states not concerned with interoperability. The researchers' approach is motivated by three premises: the ubiquity of foundation language models leading to multiple specialized conversational agents, the need for these agents to collaborate to achieve tasks, and the potential for this collaboration to be based on unstructured natural language. If these premises prove correct, there will be a need for interoperability between AIs using different underlying architectures and technologies. Conversational AI agents, classified as serving and demanding agents, interact and manage conversations through a universal JSON structure, the OVON conversation envelope. Serving agents provide services, information, or assistance, while demanding agents initiate requests or tasks. State diagrams illustrate the states and transitions of both agent types during normal and unsuccessful conversations. In successful conversations, serving agents transition from idle to ready upon receiving an invite event, then to searching for response upon receiving an utterance or whisper event. After finding a response, they move to sending response and return to ready for further interactions. Demanding agents start in the idle state, moving to ready upon sending an invite event, and then to consuming response upon receiving a response. In unsuccessful conversations, serving agents failed to find a response, terminating the conversation and returning to idle. Demanding agents can return to ready for further interactions or terminate the conversation and return to idle. Interoperable assistant manifest diagrams enable agents to describe their capabilities, facilitating discovery of agents with specific capabilities. State diagrams illustrate the states and transitions related to demanding agents searching for manifest details or assistants capable of accomplishing specific tasks. Natural language-based APIs, similar to whisper events, can be used to search for potential serving agents. The Smart Errands use case demonstrates the interaction of multiple agents coordinating and optimizing errands according to universal open API specifications. A human, Emmett, interacts with his general AI assistant, Cassandra, who facilitates transactions with AI assistants at various service points. The conversation illustrates the use of natural language-based APIs to search for capable agents and coordinate errands, employing various language models, including GPT 3.5 Turbo and GPT 4o, to facilitate transactions. This research presents two use cases demonstrating the capabilities of Open Value Network, OVON, in facilitating seamless conversations between humans and AI assistants across various domains. The first use case showcases the efficient management of tasks by AI agents, independent of the underlying large language models, LLMs, and AI technologies deployed. A sequence diagram illustrates the OVON conversation envelope messages exchanged between agents. The second use case involves an experiment providing conversational AI chatbot support to Estonian citizens, where AI assistants collaborate to provide support for a human user, Lee, who needs assistance with literature research. The AI assistants utilize different LLM technologies, including GPT 3.5 Turbo and Mistral 7B Instruct v0.3. The proposed framework for conversational AI agents enables coordination and specialization among agents, independent of the underlying LLMs and conversational AI technologies deployed. This is illustrated in the second use case, where Yuri coordinates with Andres to identify the appropriate assistant, Kaya, to provide information on books by Lydia Koidula. The OVON sequence diagram shows the exchange of messages between agents. The framework's ability to provide coordinated, specialized support is versatile and adaptable, and can integrate various technologies to meet specific user needs. Future enhancements include representing multimodal interchanges among agents, supporting multi-party conversations, and exchanging background information and context. To address conversational AI security, ethics, and accountability, additional enhancements can be considered, such as an enhanced authentication, authorization, and accounting framework, bias mitigation mechanisms, and transparency guidelines. The proposed approach based on open APIs for agentic natural language multimodal communications offers significant advancements in enabling independent conversational assistants to collaborate. The OVON specifications and sandbox provide an open repository for replicable and accessible conversational AI assistants. The authors acknowledge the contributions of the Open Voice Interoperability team to the development of interoperable standards, citing references from the Stanford Encyclopedia of Philosophy, Springer Nature AI Ethics, and the W3C recommendation on multimodal architecture and interfaces. They highlight the importance of interoperability in conversational AI, referencing Gosmar's on-life evolution model and conversational hyperconvergence. The interoperable conversation envelope specification is detailed, comprising events such as invite, utterance, buy, request manifest, publish manifest, find assistant, and propose assistant, designed to facilitate seamless communication between systems. The Open Voice Trustmark Initiative and Open Voice Sandbox repository are mentioned, promoting trust and security in voice-based interactions and providing a platform for testing interoperable voice applications, respectively. The Bureaucrat Virtual Assistant and Interoperability Initiative of the Open Voice Network are referenced, emphasizing the need for standardized frameworks and specifications for seamless communication and trust. The Conversation Envelope Object, a key component of the OVN's universal APIs for voice interoperation, is structured to encapsulate voice conversations, enabling communication between different platforms and services. The object structure includes schema version, conversation ID, sender information, and events, which are further divided into types with parameters. A practical application is demonstrated through an HTTPS POST request example, showcasing the flexibility and versatility of the conversation envelope format in sending utterance and whisper events to a smart library AI assistant. The conversation envelope object structure and implementation provide a comprehensive framework for standardizing voice conversations, facilitating efficient communication, enhancing interoperability, and promoting the development of sophisticated voice-based applications and services. The conversation envelope JSON post response example illustrates the structure of data exchanged between the smart library AI agent and the client, including a schema version, conversation ID, sender information, response code, and a list of events. In this case, the event is an utterance with parameters including the speaker ID, start time, and features such as text and tokens. The response code is 200, indicating a successful request. The Assistant Manifest Object Structure example provides a detailed description of the Smart Library AI agent's capabilities and metadata. The manifest includes identification information, such as the service endpoint, organization, and conversational name. The Capabilities section of the manifest lists the AI agent's keywords, languages, descriptive texts, modalities, and content type. In this example, the AI agent is capable of providing information about books and authors in English, ENIS, and supports text-based modalities. The content type is specified as application, JSON, indicating that the AI agent responds with JSON formatted data. The conversation envelope JSON post request example demonstrates a request manifest event sent to a smart library AI assistant specialized in author and book information. The request contains essential information, including the conversation ID, sender details, and event type. In response to the request manifest event, the Smart Library AI assistant generates a JSON response, which includes the publish manifest event type, conveying the AI assistant's capabilities and identification information. This exchange demonstrates the effectiveness of the OVON universal APIs in facilitating conversations between AI agents and bots, enabling the seamless exchange of information and capabilities. Here is a combined summary of pages 21 and 22. The appendix presents two sequence diagrams showcasing the interoperability of AI assistants in distinct settings. Figure 7 illustrates the interoperable AI assistant scenario for errands, where a user's request triggers a sequence of events, involving the AI assistant's processing and delegation of tasks to other AI systems. The diagram highlights the standardized communication protocols and interfaces enabling the interoperability of AI systems from different vendors. The sequence of events demonstrates how AI systems can seamlessly interact to facilitate task completion, emphasizing the role of standardized protocols and interfaces in achieving interoperability. Figure 8 presents the interoperable Smart Library AI assistant scenario for citizens, depicting the integration of AI-powered services in a smart library setting. The sequence diagram illustrates how users can access and utilize various AI-driven services, such as book recommendations and language translation, through a unified interface. The diagram emphasizes the role of standardized APIs and data formats in facilitating the seamless exchange of information between AI systems. Both sequence diagrams can be generated by running the sandbox environment available in the provided repository, allowing researchers to replicate and extend these scenarios. The interoperability of AI assistants is facilitated by the adoption of standardized protocols and interfaces, enabling the integration of AI systems from different vendors and domains. These scenarios demonstrate the potential of interoperable AI assistants to enhance user experiences and improve the efficiency of AI-driven services in various settings. The presented sequence diagrams provide a detailed visualization of the interactions between AI systems, highlighting the complexity and feasibility of achieving interoperability in real-world applications.